Right. So we'll continue where we left off. We were doing ray tracing exercises. We had done until 1D rays and segments, and now we are going to do section 2 in this video, which has 5 tips on tensor operations and a couple of exercises. One on implementing intersection of rays, but this time in a batch, and then making rays in 2D also in batch. Assume. Okay, let's go through these tips. Tip 1, element-wise logical operations. Use single and or and tilde. Here, x and y returns the tensor with elements x of I and y of I. Okay. Don't use the regular keywords on tensors. Be careful about the precedence. Throw in the parenthesis to force a particular order to make it clear. Tip 2, inops. You'll need to know inops dot repeat. Yeah, think we know this already. Logical reductions. Tip number 3. Okay, use dot any and dot all. They accept the dimension. Tip number 4, broadcasting. Think we've read on this briefly. Tip number 5, indexing. It's a pretty deep topic. Using ellipses to avoid repeated colons and to write indexing expressions to work. Boolean indexing allows you to select elements of a tensor based on the corresponding Boolean tensor. Okay, you have tensor D, you have tensor E, saying E of hmm. Right, so he has shape 3 comma 2, and if we pass in this for the row indices, we're just saying pick first and the last row. So his shape will be 2 comma 2. Hmm. Okay, we'll probably come back to this if we get stuck somewhere. So we'll implement the patched version of the previous version, multiple rays, multiple segments. Return a boolean for each ray, indicating whether any segment intersects with that ray. Hmm. Okay, figure out which matrices have zero determinant, replace them with the identity matrix, so it will have a trivial solution. And find the matrices such that s comma u comma v are in the required range, and our original matrix was non-singular. Okay. Hmm. What's S? I forgot what's S. Let's go up. I don't know what they're talking about. Hmm. Okay, the first thing I want to do is um, repeat rays and segments so that they line up perfectly. What I mean is uh, each ray will line up with all possible segments. So you have all pairwise matching possible. So I can do that with inobs start repeat. Uh, and raise 2 comma 3. Let's make it s2 3, where n s is segments dot shape of 0. Similarly, repeat this ns2 3. This should also be nr ns2 3, where nr is dot shape of 0. And now I need to isolate uh, the matrices. Let's go up here, close this. Uh, yeah, I need to get L1, L2, origin and distance. Rays of so I need the first two dimensions. I need everything. And from the second dimension for origin, I need the first value. For the direction, I need the second value, and I can ignore the z coordinate. Similarly, for line 1, line 2, oh, I'm sorry, segments 1, and now I just need to, sorry, what was the equation again? Uh, L1 minus, so I think I'll just take this, right, and think this should be -1. D is of shape NR and S curved NR and S2. Yeah. So if I go back here, I'll have many more rows for all possible pairs. And actually, I'm not sure, but I'll come back to this. Uh, Now I need to find the determinant of the matrix A. Actually, let me do this. Hmm. One E minus 8. That's the threshold. Uh, hmm. And so finally, I can get the solution. So to get the intersection, we need to know if u is greater than or equal to 0. And v greater than or equal to 0, and v less than or equal to 1, and right. We just have to return uh, this. Let's track the shapes, right? Okay. Shape is NR, NS to, yeah, and similarly this is, and this should be NR, NS to, and this would be NR, NS. This would be NR, NS. This is fine. U comma V should be, this should also be NR, NS. This should be NR, NS. This should be NR. Let's run it and see. Hmm. Is this the problem? Hmm. Interesting. Too many values to unpack. Ah, okay. What does this return? Let's look at this. Uh, So input is nr and s 2 by 2. Other is nr and s 2. So 932. Hmm. So this will be not equal. Hmm. I'm missing something. Uh, how are we doing? The mask settings high. That's pretty much what I have done. Oh, is that so? Oh no. Ah, isn't that what I've done? 101 2222. So, huh, -1 is the same as 1 because this is a, yeah, what's the difference, guys? Uh, da, da, da. Hmm, what am I missing? Oh, supposed to be is somewhat. Here I am. Hmm, 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 hmm. Yeah, let's throw in these uh, the shape. Hmm. Hmm, and what else? Hmm, 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 hmm. Is there a mistake in the equation? Hmm, this one. Find the domain of the matrix. Guess the absolutes. I think that's the only difference I can see. Ha, 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 ha. Oh, damn. Okay. And it says absolutes here. Hmm. Interesting. Let's go up to determinant. Okay. All right. We were almost close to that solution. Okay, this is a section on using GPT to understand code. Right. So just jump to GPT. Yeah, it's valuable to think about a problem for a while. Hmm. Okay, I guess I'm going to try this with. What's up with that? Yeah. So, copy this. Expand the doc string. Include type information. Hmm. Expanded dimensions for reasons using inops.repeat. Uh, what does it mean? Ah, pretty cool. Hmm. Guess that was useful. Learned a thing or two. Now, we're going to make use of the z dimension and have res emitted from the origin in both dimensions. Implement make res to analogously to make res 1 pyramid with the tip at the origin. Hmm. It's called res e dot zeros shape and alternate direction, and rays of the x coordinate for each direction should be 1. And now the y's would be e dot in space start y limit, this y limit steps is y, and that's speed space minus z limit plus z limit steps would be num pixels z. Thing surprising so far, and we need to fill this up in a way that have all pairs of y comma z, and because we use broadcasting, so stop and squeeze, um, so that it goes from shape num pixels y to x y comma 1. Similarly, but not exactly the same, going to do and squeeze, but it's 0, so it goes from nz to 1 comma nz, and rays of I think INOPS or repeat is what we need. Let's call it in y. Ah, and yeah, I don't think we do, or can we? Yeah, I think this is the way. Said, does it pass? It looks good to me. Let's look at solution. Yeah, they repeat. Yeah, pretty much the same thing in a different order. We're good. So, yeah, it's pretty late. I think that's it for this stream. Next stream, let's do triangles. And yeah, guess it's 1 and 2 and 3. And video lightning has 1, 2, and 3 exercises, and we'll have a Pikachu. Pretty cool. Okay, all right. See you guys. Thank you.